Everyone, we are here at Automate with Zach. We're talking about Cinematik Run My Robot. Longtime viewers will have seen me at the Autonomous Factory Lab at the Siemens Nuremberg facility, going and talking about it with one of the Comile robots behind us. But here, Zach, we're talking about simulation of what those robots look like, and we're talking about additive. Can you tell us a little bit more about this, please?
Of course. So when you talk about traditional robots, they're very repeatable, but they're not very accurate when you have a high variability with your path.
Yes.
So what Siemens has done is it's married a traditional robot arm with a traditional CNC controller.
Yeah.
So we've taken our CNC controller and all the benefits that come with that, compensation, traditional CNC functionality, look ahead and compressor functionality, and put that so that your robot, for whatever the application is, milling or additive manufacturing, so directed energy deposition or material extrusion, you can have a higher accuracy application with that. So what we're showing is create my virtual machine and run my virtual machine, both the operate and the 3D version of it, so that you can see what the actual controller is reading in, the interface, the HMI, which is very helpful for controls engineers from a commissioning standpoint, but then also how is that robot moving? Because when you start to get to higher levels and degrees of freedom, you really need to understand what your part program is going to do and how you're tying in the end effector.
Absolutely.
For additive, it's super important.
And let me ask you as a follow-up, right? So you mentioned that one of the benefits is obviously precision. Are there any other benefits or things that you can maybe do better now with the CNC controller paired with the robot that you couldn't do before? Maybe what could customers expect as an added benefit to that?
So when I say precision or accuracy, there's many different flares to that. So you talk about how the actual path is going to be followed. That's one piece of it. Another one is from robot serial number 1 to robot serial number 2, the linkages are going to be a little bit different. So you have to even compensate for that. We call it static accuracy. There's a way to do that also with the Cinematik controllers. But even more so outside of the accuracy piece is tying in the end effector. For additive manufacturing, one of the ways that people look at how you deposit material is you want it to be the exact same path velocity. So constantly, a constant velocity. But that doesn't always happen in real life. So how do you change how much material you'll be pushing out and depositing wherever that is? And because of the functions of the Siemens CNC, you're able to do that. And it's not the reason we created Run My Robot, but it's a nice thing for the additive industry because it's there.
Absolutely. So I've worked in aviation and aerospace before. I've seen similar applications, mostly on the drilling, milling things, but the additive, that seems interesting, right? We're only ever going to make so many airplanes every year, but it seems like additive is continuing to grow. Are Cinematik Run My Robot, are you guys seeing a lot more demand or a lot more interest in these applications for the additive industry?
Yes, I would say a majority of the applications of who's interested in Run My Robot right now is additive manufacturing. But it's not just additive. A lot of the times it's a hybrid functionality. You'll change out the end effector from a D head to a milling head or a scanning head, something like that. And yes, aerospace is probably the leader in a lot of areas like this, but it's not the only one. There's a lot of application.
That as a follow-up, maybe what kind of verticals are you seeing utilizing additive, or it could be even subtractive CNC for that matter, as an added benefit? Because I think as the costs come down, as precision increases, there must be more industries willing to enter into those use cases. So maybe can you give us a landscape or an overview of different industries?
So aerospace and defense is a big one, the defense aspect of it. And it's really going into MRO. So think about repair functionality. You have a tank, you have a large piece on a ship, anything like that. It's normally really expensive to produce, maybe through a casting or something like that. Can you repair that, whatever it might be? That's a big piece, particularly with robots, how flexible they are. Flexibility, not just with how they're operated, but even the footprint of where they can go. Put them on a rail, they're as big as a big gantry that's the size of a football field. Why not? When you pair a Siemens CNC with a robot, robots is a change that has been happening for the automation world for a while. But there's a lot of programmers that know traditional CNCs, right?
Yes.
What this gives you is a little bit taste of how do I program that robot that's similar to a CNC.
Okay.
So you don't have to retrain as much. You're already a majority of the way there because the interface is the same, the functionality is the same, how you understand how it's going to move is the same as that 3-5-axis mill that you've been standing in front of for 20 years.
Interesting. Huh. I would not have thought that would be the case, but I'm assuming it's also going to simplify some of that programming process nowadays than it used to be even multiple years ago. Or are you seeing the programming of these machines become simpler?
I'll actually have to say they might have actually become a little bit more difficult.
Okay.
And the reason for that is traditional robots, when it's pick and place, they think of it as a teach pendant. And that's really simple. You just press, okay, teach in, teach in. Now we're actually talking about true offline programming.
Yeah.
So it might be more difficult in some ways, but overarchingly, as a lot more people are coming out of universities trying to be more digital native, let's say, as a buzzword, right? It might be easier for them because they're actually learning as a digital twin mindset first. It's both harder and easier.
And I'm like, because I'm just like thinking, I know how difficult robots are as like, I guess, the hardware and the software that organizes that. And I'm assuming Siemens like abstracts all of that, right, as you program the CNC. But how close is it maybe to a traditional like 3D printer, right, where you have the slices and the layers? I think here it's going to be different, but is it?
So in the software platforms for Siemens, we have something called NX, and there's a functionality called multi-axis deposition. So whether it be material extrusion or directed energy deposition, we do multi-axis deposition. With that, it's not a pure slicer. You're not taking apart and cutting it layer by layer, but instead you're actually building it up with beads almost. So then how you deconstruct the part and rebuild it becomes a little bit more intricate. Because of the higher degrees of freedom, it's not just a 2+1 like a slicer. But at the same time, it's cooler, it's more flexible. There's more things that you could do it.
No, that's why I asked, right? Because I know how the slicers work, and it's just a limitation that it's a 3-axis, just a gantry that's moving up and down. But with robots, you can do some really cool stuff. But
I think it's really interesting being able to go reskill or upskill or use the same CNC skills that are like hard fought, hard learned programming skills and be able to use those in very similar manners for robotics. We talk about a lack of robotics programmers because we're trying to deploy so many thousands and tens of thousands of robots. I'm not sure I've ever had the conversation where people are like, hey, we can go take your CNC operators and use the vast majority of that knowledge and go ahead and drive that into going and getting these robotic applications up and running.
Yeah, I think it's super useful. And it's a marketing term, a game changer, or however you want to say it. There's certain aspects that are harder. There's a lot of aspects that are reutilized, and that's a good thing.